All right, buddy. So for today, we're going to start getting ready for the Unit 9 test. And as you can see on the screen, make sure that you are on page 29. Now, once you're on page 29, you have to understand this left side is the we do. This over here, the right side, is basically your classwork / homework. So because it is a minimum day, we may not have enough time to even get started, but you are about to see a copy of the test in the we do's. And then, of course, you're going to practice your own copy of the test with the you do's. Again, very important assignment. Make sure you get it done this weekend. That's how you're going to prepare for our Unit 9 test. So with that said, let's get started. First one says simplify. If you notice, it doesn't say to round off. So if it doesn't say to round off, that doesn't mean you just toss this into the calculator. You need to start asking yourself, is the number 48 a perfect square? So good time to have your word wall out. The number 48 is not on my list, but the number 48 would fall between the 36 and the 49. So because it's not on my list, then the first thing I do is I write down two radicals. One is the one that I'm going to be able to do some work with, and the other one is the one we like to call the leftover because I can't do anything with it. So here's what we do. We get our calculator going. Once we have our calculator, remember we are going to be testing a couple numbers here and there. So we're going to start off with the 48, and then I'm going to divide it by, well, remember when we looked at the list, my number's between 36 and 49. We already know 36 won't work. It's too close. So I'm going to start with the 25. And if that fails, well, then I'm going to move it up to the 16. Remember, we work our way up the list, not down the list. All right, so 48 divided by 25. And nope, that didn't work. We got a decimal for it. So here I go again, 48 divided by. Next number on the list is 16. And there it is. Look at that, just two tries. We are going to be using the two numbers. No, it's not just the 3. It's the 16 and the 3. The 16 is the one that's on my list. The 3 would be my leftover. So now all I have to do is take an actual square root. So according to our word wall, or you just know the fact that the square root of 16 is 4, then the 4 comes outside of the radical. The idea is something needs to come out, and then the 3 is a leftover because we just leave it inside. Can't do anything with it. This is what they mean by reducing a radical, simplifying a radical, whatever you want to call it, something's got to come out of that square root. So we look at number 2. When I look at number 2, I'm asking the same question. The question is the number 36 a perfect square? Well, let's look. Yeah, 36 is on my list, so I don't need to split that up. See, we split it up here because that didn't work. The 36 is fine. But we do have a letter involved in the problem. The letter being used is the x to the power of 9. Well, remember, when it comes to letters, the question is, can you split 9 x's perfectly down the middle, right? Can you cut it in half? And the answer is no. That's an odd number. So because of that, we are going to do a split. Remember, one is the one that you can do work with. The other one is just your leftovers. But remember, the 36 was fine. So the 36 was okay. Then I'm going to put that in here. I'm not going to put it in leftovers. That's on my list. But X was the issue. So if X is the issue, then all I have to do is just give each one an X. And if you remember the pattern, since I'm trying to get an even number out of it, my leftover is always X to the 1. Always one leftover. Which means if I need 9, this is 1, then this is just an 8. Together, they make that 9. All right, but you see, we're ready. I'm ready to do the work. This is a leftover, so I could even write that in already. Nothing is going to happen to this, so leave it alone. But now I can use my word wall. The square root of 36 is 6. There's an x next to it, so I instantly write the x without thinking about it. But remember, we are cutting it in half. Because there's a little index of 2, we're cutting in half. So 8 divided by 2, there's our 4. And just like that, there's the answer to this problem. Remember, letters gets cut, right? We cut them right in half. The 9 didn't work, so I split it so that the 8 can be cut in half. And yes, this is always going to be a 1. Now, looking at number 3, we don't have letters, but we do have 2 numbers inside of the radical. And what we said was, well, if you have 2 numbers inside a radical and there's division, let's split them up. Give each one their own square root. So now we question it, of course. 3, well, 3 is definitely not on my list of perfect squares. And if you think about it, the only numbers that multiply to give me a 3 are 3 and 1. So splitting it doesn't work either, which means leave it alone. Can't do anything with it. But the square root of 25, that is on my list. The square root of 25 is just 5, which means you're going to stretch out that fraction. And then there's your 5 on the bottom with no radical. That's the whole point of taking a square root. Something came out. And just like that, I'm already done with that one too. Remember, with radicals, if they work out nicely, there is no splitting. And if you try to split it and it doesn't work, well, then just leave it alone. Which brings us to the last concept about radicals that we discussed in this unit. Again, it says simplify. That's not really math talk. You look here and it's just a bunch of adding and subtracting. Well, then that's what I'm going to do. But remember, radicals behave just like variables. This is a radical 7. That's not a radical 7, but this one is. See, this one over here has a radical 5. That's completely different. So if they want me to add and subtract, just like with letters, you can only add and subtract numbers in the front. And I'm adding and combining these two. Again, these two are being combined because they both say radical 7. So look, here's that radical 7 and positive 3 minus 8. Do the math carefully. Negative 5. Again, you never add the insides of radicals. We're only combining outside values. And then, of course, there was this 3 radical 5, but you can't join it with anybody. It has a radical 5, completely different than everybody else. So then just write it down. And if you're thinking, oh, well, now I see 5s. Yeah, but again, the radicals are different, which means I'm done. You only combine what you can. You did it with letters. You do the same thing with radicals. But yes, one key thing that we just mentioned, don't forget, we never add inside numbers. They are called radicands. That's the official name of it. But we never add those inside numbers. That 7 and 7 just stays a 7. But we never add inside numbers, just outside values. So yeah, radicands, that's the official name. We leave those alone. All right, which brings us to the last problem again. These are the same problems that you see on this side. This is your practice. That left side is going to be your assignment. So let's do this last problem on this page now. It says, use the graph to solve the equation. All right, well, first of all, a couple things. One, is this a quadratic? Absolutely. Look at that power of 2. That's what makes it a quadratic, and that's why we have this graph of a parabola, because a parabola describes or is the graph of a quadratic equation. The other thing we need to remember is when they say the word solve, remember, everything we've done this year that says solve, it's really asking me to do one thing. You're going to find x-intercepts. The solutions to a quadratic are x-intercepts. X-intercepts are the solutions to a quadratic. So I could do this 2 ways. Number 1, I can factor this, or I could use a quadratic formula. I have the space at the bottom. But why waste our time doing that? See, if you look at the problem, they said, tell me what the x-intercepts are. Well, here's the x-axis. So how many times does my parabola in yellow touch the x-axis? Twice. Which means I have 2 answers for this problem. So just like that, I'm done. Look, x equals -1 and x equals 3. If you are giving the visual, right? If we have the graph, then all you have to do is look for the x-intercepts based off of that graph. All right. Once you're ready, let's flip the page. Remember, we are going to do all the we do problems, basically the left side, Your assignment is to practice by doing the right side. So here we go. Flip it over. See what the next question. Again, we do these together right now on video. Your homework and your classwork is all the left side for every page that we do today. So you're doing the left side as your assignment. All right, so it says, what number would you add to complete the square? Okay, well, here it is. When they say the words complete the square, there's only one thing I want. I want a power of 2. It's basically what we're being told. This number that we put in this box, I'm not sure why it's dark there. In fact, let me just do a quick fix here in case yours is 2. Let's just put a line instead. That number should be a perfect square. Again, it's got to be one of these yellow numbers on my list. That's the idea. Now, I do have something in mind. You see, it says complete the square. Just so you know, I will post a picture of this word wall online because you may want to change this box to look like this one instead. See, to start completing the square, we're going to divide the b by the number 2. 4 divided by 2 is 2, so it says factor backwards. And because it's a positive 2, well, x plus 2, and then look, we multiply. That's how we figure out what to put there. So here we go. I am going to start by taking that 14, dividing it by 2, which is 7. Once I know it's a 7, now I know what my 2 factors will be. And remember, because it's a perfect square, they have to be the same. So it's x plus 7, because it's positive, x plus 7 again. They have to be the same. But the goal was, what goes here? Well, according to my note, all I have to do is do a little multiplication. I'm going to take the 7, multiply with 7, and that's what I'm going to put in there. So 7 times 7, 49. 49 is a perfect square, and that right there is my answer. That number needs to be from your list of perfect squares, and that's how we find it. Okay. Again, I will be posting that information, the picture of my word wall, into Google Classroom. All right, now, look at the next problem here. It says round to the nearest 100. That right there means one thing. You're going to use a calculator. At the end of this problem, you have to use a calculator. That's what that means. Round it to the nearest 100. Well, now you have to ask yourself, all right, well, how many places is that? Remember the trick. It says 100th. 100th. So if I'm looking at the number 100, it's got 2 zeros, so then I'm going to go 2 places. I'm going to need 2 numbers after the decimal. That's what we do there. All right, so here we go. Now, looking at this one carefully, is it a quadratic? Absolutely. It's got a power of 2. That means I have to have 2 answers. That's the idea here. Power of 2, I can get 2 answers, maybe 1, maybe none. It could be a no solution, but definitely 2 answers for now. Now, I only have one x that I actually see. So when I have one x, see, when you look here, it says factoring. Yeah, this has 2 x's, so that's not the technique I'm going to use. This is the one. Look at that example right there. It has one x only, and so it says isolate the x squared. So get the x squared by itself, square root, but here's the most important thing. You better use that plus or minus. Why? Because we have to have 2 answers. So I only have one x. So according to the note, I'm going to add the 15 because I'm trying to get the x squared by itself. Oh, not that. X squared then is equal to 35. Now it's isolated. Well, according to my word wall, it says you're ready for a square root. So that was the thing we learned. We said a power of 2 and a square root will cancel each other out, and it leaves me with an x. But before you do anything else, the word wall does remind you, you have to have 2 answers. That is why we say plus and minus to guarantee the 2 solutions. Now, the square root of 35 doesn't really help me out. I can't take a square root. So normally I could say, okay, I'll just leave my answer like this. But they do want a decimal. So because they want a decimal, this is when we split it up. We do our split. X is equal to square root of 35. X is equal to negative, outside, not inside, square root of 35. And now we let the calculator take over. Now you notice it's the same number, so I'm just going to put a negative. And now let's let the calculator take over. We're going to type in the square roots of 35. All right, so here's what the calculator's telling me. Now remember, we did say 2 places over. So I'm going to block that out right there. So my answer is 5.91 or 5.92. Who makes the decision? Look at that, that's a 6. Then that means I do roll it up to a 92. So 5.92. And of course, that one's just negative, 5.92. And there we go. We get our 2 answers. All right. Again, power of 2, you have to have 2 answers. And of course, we bring in square roots. Now, when I look at number 13, okay, number 13 also has a power of 2. So yes, this is a quadratic. That's it. That's the only detail we need. It's a power of 2, it's a quadratic. But the question is, can I use what I did up here? Can I bring square roots into it? Look at it carefully. This thing has 2 x's written out. This one only had 1. That's why I use square roots here, but you definitely cannot use square roots on number 13. See, number 13 has 2 x's. So the first thing we want, you need 0 here. We need a 0. Well, again, stick to your basics. If this is a positive 8 and I want a 0 there, well, then get rid of it. You've learned how to move things, how to get rid of things in this class. Then keep using that skill. So we have x squared minus 2x, because it does need to be in descending order, minus 8 equals 0. All right, so here, we're ready to go. I do have 2 x's. Now I have 2 options. I can factor, which I should try first, right? Look, it has 2 x's. So factoring will be our technique. And then, of course, once you factor, it says set each one equal to 0. If you notice, that's why in my word wall, I have both of these 2 boxes within the same color because you need them to go hand in hand. But it is a quadratic, so technically I could use what we learned this week, which was the quadratic formula. But factoring might be faster, so here we go. All right, well, if I'm going to factor, I get my 2 parentheses ready. There's my 0. I get x and x in there, of course. And now we break down our 8. So we break down the 8. The 8 is 8 times 1, 4 times 2, and that's it. Those are my 2 options. That's all I have. But it's all about the goal. When you're factoring, you have to know how to pick these numbers. All you have to do is look at the number you just broke up. I broke up the 8, so that means I have to subtract, and my goal is to get negative 2. Well, if I subtract and get a 2, that's going to be these right here. Look at that. We get a 2, so I know it's got to be the number 4, and it has to be the number 2. Those are my 2 numbers. But this is why we do what we call guess and check. I really just need to double check and make sure I'm using the right numbers, first of all. So let's do a quick check. 4 times x is 4x. X times 2 is 2x. And my goal is to get subtracting. I'm going to subtract to get a negative 2x. Well, think about it. If you're subtracting, only one of them can be negative, not both, just one. Well, if you want a negative answer, then the 4 is the one that should be a negative. So there it is. That makes the 2 a positive, and it checks out. Remember, we only do this to check. All right, well, I'm not done. It says solve. It doesn't say x equals yet. So we take our last step, which is I take each factor. So I'm going to take that x minus 4, and I'm going to make it equal to 0. I'm going to take that x plus 2, and I'm going to make it equal to 0. And now just with a little solving here, look at that, add 4, right? Basics. Subtract 2 to both sides. Then I get my answer is x is equal to positive 4. There's my first answer. And x is equal to -2, remember quadratics. You're going to get two answers, two x-intercepts, two roots. Remember, they go by different names, but these are my answers or my x-intercepts for this problem. All right, and then I look at number 14. When I look at this equation, I don't see a power of 2. This is not a quadratic. You see, that's a quadratic. I do this work for quadratics. But when I look at number 14, there is no power of 2. It only has a power of 1, which means this is linear. Then this is my throwback question on the test, which you're going to have a few of. Throwback question like that. Remember, we used to put a little line down the equals? Well, that's what we're doing here. And now, stick to basics. How do I get rid of the 9? Subtract the 9. Don't confuse the easy stuff with the difficult stuff we've learned. All right, so then I end up with 4x is equal to 41 minus 9 is 32. Divide by 4. And then x is equal to 8. And look, I'm already done with that. Keep the math simple. Don't confuse the two concepts. This does not have a power of 2. I don't do any of that factoring, that radical stuff. None of that is needed. Basic. Okay? All right. Well, let's try another page. Again, this is our review. You are going over every question that will be on the test. You will practice again on the other side because that's your classwork. So now notice we get less and less problems on every page as we go. So that's why it feels like a lot, but it's just the space we need for working these problems out. Don't forget, this is the we do. You are responsible for the right side. That is your assignment. All right, here we go. Solve the equation using the quadratic formula. And why am I using a quadratic formula? Well, because it has a power of 2. Plain and simple. That's why we use them. But the key now says round, which means you're going to use a calculator. And then it says round to the nearest hundredth. Again, you're using a calculator for this. Now, again, nearest hundredth, don't forget, it's the number 100. So that means 2 numbers after the decimal. It's got 2 zeros. Then you need 2 numbers after the decimal. All right, here we go. We are doing the quadratic formula. Again, it's in your word wall. We're just going to use that one. And it says, here is my A value. Here is my B value. Here is my C value. So we get the quadratic formula ready. And it says, x is equal to, now remember, you have the quadratic formula here. This is what I'm going to use. There is a spot for every letter. All your letters are coming from the equation, your ABC. Don't forget the minus, plus or minus, the power 2. Yes, that's always a 4. So use this. Have it right next to your problem as you go. All right, let's see. X is equal to negative B plus or minus the square root of B squared minus 4 AC. See, I don't need to plug numbers in. Look, big fraction from beginning to end all over 2a. The problem when we did this the first time, many of you were too worried about putting numbers in and then you forgot the smaller details. Don't worry about the numbers. Get this stuff in first. All right, according to my word, well, look, B value is first. So 3, not 3x, just 3. Second one, B again, so 3. Third parenthesis says A, so a 4. The last one is a C, so negative 2. Don't forget that negative. And then, of course, at the bottom, 2A, so 2 and 4 again. Again, every spot belongs to a letter. Use your word wall to guide you. Give your word wall some color. It'll help out too as well. So now it's time for us to do some calculations here. This is where a calculator. Now, just remember, on the day of the test, you will have Desmos available to you, which is a little bit easier to work with. So negative 3, there's negative 3, plus or minus, square root. 2 times 4 is 8. Notice I'm taking care of the little things. Now it's time for me to start thinking about my calculator. But remember, you're not going to put this into the calculator yet. Don't use this symbol. This is what you're going to type into your calculator. So I don't have Desmos here, so I'm going to go with my old school calculator. And I'm going to type all this yellow stuff in that we see on top. Exactly the way we see it. Parentheses 3, parentheses power of 2, minus 4, parentheses 4, parentheses negative 2. You got to use that negative button. All right, look at what we get. We get a 41. That 41 is what's going to go in here. There's my 41 that the calculator gave me as a result. But remember, it is positive. So because it is a positive number, I am going to get 2 answers. And if I'm going to get 2 answers, you got to split. You got to split this thing up. So here comes my split. First one says x is equal to negative 3 plus the square root of 41 over 8. And then the other one says x is equal to negative 3 minus the square root of 41 over 8. So we're going to let the calculator take over. Again, the day of the test, you'll have Desmos available. Right now, I only have this one. So let me type this first one in. I'm going to put a parenthesis to start. Negative 3 plus the square root of 41. But notice they open a parenthesis. I'm going to close them both up. Now all my parentheses are closed. And then I'm going to press divide by 8. So yes, with these old school calculator scientific ones, you do need to let the calculator know that all of this is on the top of a fraction. And then you hit enter and there it is. They said, give me 2 numbers. So my answer is either 0.42 or 43. Well, let's see, that's a 5. Then we have to roll it up to a 43. So 0.43. All right, there's our first one. Again, you have to be careful with the use of calculators. Or just, you'll be able to use Desmos on the day of the test. All right, so now here's the same problem, but all I have to do is change it to a minus. So let me see if I'm able to go up on this one. Yep, here it is. So I'm just going to change that to a minus sign. And now I just hit enter. All right, there's my answer. Remember, my answer is either negative 1, so it's either 117 or 118, which would be the next one. And because it's a 5, we're going with negative 1.18. And there's your second answer. Remember, Desmos does make it a little bit easier, but it will be open for you on the day of the test. All right, quadratic formula again, only works for quadratic. So saying that, look at number 20. When you look at number 20, it also has a power of 2. So yes, that makes it a quadratic, which means for number 20, because it has a power of 2, could I technically do what I did up here? Absolutely. I can definitely use the quadratic formula for this one. Or we factor. So we're going to practice factoring once again, but I could use the quadratic formula instead. Now, the only difference this time, it does have a number 5 in the front. So we break it up instantly, 5 times 1. So now I have to check for GCF. Remember, when you have a number in front, you definitely check for GCF. But can the number 4 be divided by the number 5? Yeah, that's not going to happen. So if the 4 can't be divided by 5, and there's no x back here, then there is no GCF to worry about. And if there's no GCF, then we go right into our factors. We get our 2 parentheses ready. Remember, it is a 5 and a 1, so don't just write xx. You should be writing 5x and 1x. So now we do need to break down our numbers. So I'm going to look at the number 12. 12 is 12 times 1, 6 times 2, and 4, run out of space there, times 3 is my other option. So I do have a couple there to pick from, but don't forget the goal. The goal for this problem, right, I broke down the 12, is to subtract again to get a positive 4. All right, but this one you definitely have to check because remember, one of the things you're going to do is you're not just going to write the two numbers. See, none of these subtract to give you a 4. Actually, these do. But you got to multiply one of your numbers by 5, and that's the catch. The fact that you have to multiply something by 5 first. All right, so let's see. 12 times 5 on my calculator is 60. Way too much for a number 4. So that's not going to work. 5 times 6 is 30. But 30 take away 2, well, that's too much again. So this didn't work. Let's see. 5 times 4. 5 times 4 is 20. Take away 3. You see, still too much. Remember, you got to remember it's subtracting. So the 5 didn't work for any of these numbers. So now I'm going to try them over here. 5 times 3 is 15. 15 take away 4, not a 4. So that's not working now. 5 times 2 is 10. And if I take away 6, there it is. That's what we want. So the 5 should be multiplied with the 2. 5 times 2, look at that. We get a 10x. The other one is a 6. 6 times x is 6x. And we said the goal is they're going to subtract to give me a 4. Well, if I'm subtracting and I want to end up with a positive number, then who's the negative? Well, if you're thinking the 6, you're right. Negative 6 and positive 10, there's the 4. It checks out. So this is the negative. This is the positive. All right, we're ready. Everything has been factored for us. So now we're going to go 5x minus 6 equals 0. And then for the other one, we're going to make x plus 2 is equal to 0. Now this one's a little bit easier to do. All we have to do is subtract the 2 from this one. And then we're done. X equals negative 2. So there's one of my answers. And then here we add the 6. But we're not quite done yet. We still have that 5 to get rid of. And then I divide by 5. And just remember, if it doesn't divide nicely, it's okay. Just leave it as a fraction. We've had a lot of those this year. So 6 over 5. All right. Quadratics, everybody. We only do factoring. We only do quadratic formula, of course, if we're dealing with quadratics, powers of 2. We don't do it for anything else. All right, now here comes another throwback question. The reason we're getting all these throwback questions is because the final's coming up. It's not that far away. It's over a month still, but it's going to go by quickly. So here's another throwback question. It is talking about slope. And then notice they gave me 2 points. So if they're talking about slope, then we have to remember that slope is represented by a letter M. And we always say rise over run. But the other thing to remember is we can find the rise with easy subtraction. We can find the run with subtraction again. But the one thing you have to remember is what letters go on top? What letters go at the bottom? Remember, it's called rise for a reason because you're going up or actually down. Well, the only letter that goes up and down, right, in math is our y values. Our y values are the ones that go up and down. So then the run, which means side to side, would be our x's. And yes, that's why we have 2 of them. But to organize it and to make sure that we put things in the right order, one of the things that we did in class was we wrote the points one on top of the other. We wrote them like this. Because now all I have to remember is the y's are on top, and I'm going to go in that order. The x's are going to be at the bottom, and if my x's are at the bottom, well, I'm also going to go in that same order, and that was the key. So we're ready. Slope is equal to a fraction minus signs. All right, here come the y's. Negative 14, then the 10. Negative 14 and then the 10. Here come the x's, 5 and then 9. 5 and then 9. All right, let's do the basic math. Negative 4 minus 10, negative 24. 5 minus 9, well, think about it for a moment there. Negative 4. And then finally, a fraction means division. Again, we always take it down to basics. If this means division, negative 24 divided by negative 4 is simply positive 6. And just like that, we have the slope of our line. All right, so once again, there's going to be a few of these throwback questions. We just have to be ready for them.